So this is a walkthrough of my code. So we'll start off with the first file, music parsing. Music parsing takes the Music21 API and uses converter to get the instruments, the notes, and the chords, so that you can parse the dataset of music easily, so that it can later be sequenced into a suitable format for the LSTM. So this will essentially go through the dataset and parse each note, and then it will create two arrays, one of the notes and one of chords. So the chords are designed differently so that they can later be encoded by this file, which takes the notes and enumerates them and turns them into a dictionary, matching the pitches to integers. And this dictionary will later be used to take stuff generated by the network and convert it back. So this will return the network input and output for the LSTM, where the LSTM will then take this from data sequencing.datastructuring, and it will get the notes, and then it will create the model. So the model here is the architecture. This architecture it's pretty simple. It's 3 LSTM layers, a batch normalization layer, a dropout layer, a dense layer with 256 units, then an activation layer. So this just ensures that anything below zero becomes zero, just to keep the bounds between 0 and -1. No, sorry, 0 and 1. Oh my god. Yeah, and then another batch normalization layer, a dropout layer to just smooth the network, and then another dense layer, the length of the note array, and then an activation layer, softmax layer, and then compile it using the cross entropy loss function. And then this checkpoint, this stuff basically, it takes the weights that have been pickled, because is it pickled? Yeah, I think it is pickled, or it's been stored in these HDF files so that it can be reused. So because I've already had my model crash once at 28 epochs, and that was really annoying. So that this helps me like recover my model essentially, and then this will train the model main.py, and then make prediction. It will be running in the predict.py, which essentially does the same thing as the LSTM model, except it makes a prediction off of it rather than trains it. So that's just a walkthrough of my code. Thanks.